Right, guys, let's have a look at this one then. 5b. The first term of another geometric series is 5, and the common ratio is 1.1. Let's just do part 1 to start with. We'll come back to reading that in a minute. The nth term of the series is 170. Correct the nearest integer. Find the value of n. Okay, so I've written all that down on the notepad. So the first term is 5. The common ratio is 1.1. The nth term to the nearest number is 170, and find n. Okay, so the first term, and the geometric series which we've got is AR squared, and so on. So the first term is A, and we're told that's 5. We're told that the common ratio is 1.1, so we can put that down straight away. Yeah, and we're told the nth term. Now the nth term is AR to the n minus 1, isn't it? That's the nth term. Because this is the third term, which is 1 power less. This is the second term. It's always 1 power less, so the nth term is 1 power less. AR to the n minus 1 is 170. So put the values in there. 5 times 1.1 to the n minus 1 is roughly equal to 170. So that's 5 times. Okay, so divide by 5 both sides. 1.1 to the n minus 1 equals 170 over 5. Tap that in the calculator if you need to, you get 34. Now to get this down to ground level, we'll take logs both sides. Take in logs then. Gives, and I'm talking about natural logarithms here. So log of the left equals the natural logarithm of the right. Okay, now the properties of logs, this little chap in here swings down to ground level there. So you get n minus 1. More than one term, put bracket. Log of 1.1 equals log of 34. Agreed? So now divide by log 1.1, so n minus 1 equals both sides. That moves that from times to divide. So there's a lot of algebra in this question over log 1.1. And then basically that will tell you that n then equals log 34 over log 1.1. And then the minus 1 moves across to plus 1. There we go. So let's tap that in the calculator then. So tapping it in the calculator, log 34, it's natural logarithm, 34 divided by 1.1 log of, that's that, equals, and then I'm going to add 1 to that, plus 1 equals, I've done it that way around, 37.99, so I think it was 38. 38, yeah? So that would be our guess, approximately 38. That's to the nearest whole number. So n is 38. Because it was so close that it's got to be 38. Now we'll do the next part of the problem here. Just up here, part 2. So let's have a look at part 2 and see what it says. Back up here. Part 2. David, who has been using his calculator to investigate various properties of his geometric series, claims that the sum to infinity of the series is 940. Explain why this result cannot possibly be correct. So, back on our stuff. S infinity equals 940 is what David is claiming. Can that be true? Not possible. Why is it not possible? Why have I written that down so quickly? Since, well, in order to have a sum for infinity, r needs to be less than 1, doesn't it? To have a convergent series, a convergent sum. So we got 1.1, since r is bigger than 1. So that's the reason it's not convergent. So it shoots off to infinity. And you could illustrate that with putting in the term. So S infinity, no, it's not possible since the common ratio is greater than 1. And r must be less than 1 for S infinity to exist. Yeah? So I think that's all you need to say, a little sentence on that. That's part 2. I've put it up there, sorry, because I've run out of room in this page, and I wanted to keep it all on one page. Okay then, that's 5 part B done. Parts 1 and 2. This is part 2 here. This would be part 1 and is 38. You might want to try and just tap that in to show that and verify when you tap in this here. Well, let's just do that quickly, shall we? So it would be 5 times 1.1 to the power, and it was 38, and we claim that that's equal to 187. AR to the n minus 1, sorry, that's 37, because that would be the nth term. So it's 37, yeah? Yeah, 170 to the nearest digit. Good, that's what we wanted, so yeah, that's fine. That answer there is okay. And yeah, that's fine. And we've mentioned that part convergence series. Okay, good. Let's go on to the next part. Great.